Some more work with limits. If we look at example A, as x approaches 1, we can see that the height of the function, or the y values, also approach 1. As x approaches -5, you can see that the function approaches heights or y values of 5. Again, as x approaches 0, function approaches a height of 0. As x approaches 3, we have a hole in the graph again. Likewise, with the last example, the hole in the graph doesn't matter. We only need to know what the graph approaches. It approaches a height of 2. E, we start dealing with one-sided limits. X approaches -4 plus means x approaches -4 from the right side. So we're approaching -4 like this. With a one-sided limit, it only matters what we approach the function from that side. So on that side, the function approaches 1. With f, we're still approaching -4, but this time from the left. So we're coming into -4 like so. From that side, the function is approaching a height of 3. With g, now we just have x approaching -4, which means we need to come in from both sides, the left and the right. But as we do that, the function's approaching 2 different heights. Now, when the function approaches 2 different heights, we don't average them together, we don't do anything special. That limit does not exist. I'm going to use DNE as an abbreviation. So on h, we have x approaching 2 from the right, so we're coming in like so. That graph keeps climbing forever, so as x approaches 2 from the right, the height of the function approaches infinity. I, x approaching 2 from the left, so we come in like so. Again, climbing, so as x approaches -2 from the left, we also approach infinity. J, now we just have x approaching 2, so we need to come in from both sides, the left and the right. And we can see as we come in from both sides, the limit of that function approaches infinity from both the left and the right. So as x approaches 2, that limit is infinity. Example K, x approaches -2 from the left. So we're coming in from the left. That function is climbing to infinity. L, x approaches -2 from the right. That function is moving down to -infinity. M, x approaches -2. This is from the left and the right. We can see by the last two examples that the function didn't approach the same value. Infinity climbing up, -infinity is climbing down, so this limit does not exist. Lastly, with our limits at infinity, with number n, letter n that is, x approaches infinity means we are going as far out to the right as we can get. That function has a horizontal asymptote there at 1, so that limit is 1. O, as x approaches -infinity, we go as far to the left as we can get. That function does keep climbing forever as we go to the left, so as x approaches -infinity, that limit approaches infinity.